So this presentation is, of course, on the tools, techniques, and solutions to avoid a big data blowout in your org. If you do it wrong, you will blow out your database. There's no doubt. We were called in April of this year with exactly that problem. We had a client that simply couldn't run their database. They couldn't run queries. They couldn't do list views. The thing came to a crashing halt. And so they called us in and they asked us how to change things in order to run performant queries. And it was a fun project. And we learned a few things during that process. Some of them are obvious, some of them are not so obvious. And I'll go over, I think, 6 items that I think are critical in order to build a performant database. There's a couple in addition to that since we built the slides, I've debated whether to bring those up, and we'll at least informally touch on those as well. Let me find my clicker here. So my name is Moyaz Thanawala. There's no reason to memorize that name. There's not going to be a quiz. I've been in the Salesforce arena for 5 years. Sorry, I've been leading the Dallas developers group for 5 years. I've been in the Salesforce arena for about 10. And prior to that, I was a .NET engineer, starting back when Carnegie and Ritchie introduced their C book in the 80s. So I'm dating myself here, but I've been at this, I think, a little bit longer than I should. I run a company out of Dallas, appropriately named Thanawala Digital. Our clients are mainly Fortune 50 type clients, and so they have large databases. And this is, of course, the trend I was talking about earlier, was even with our large clients, we were seeing 5 million records in their Salesforce org. And this year, it's grown a magnitude. We're seeing a lot of 50 million records, which frightened me a little bit because exponential growth is still, a factor of 10 is enormous. So it's not the same clients that have 50 million records, but we're seeing more and more clients that have 10 million plus records. You can find me at http://t.digital. So big data is fine, but there's something a little bit more interesting that we need to look at. Earlier this year, Entrepreneur magazine actually rang the alarm bell, right? They published an article and said that what they were seeing was that the need to tackle big data and make it performant, not just store the big data in your system, but to make it performant was the key challenge that IT departments we're going to face in the next couple of years. It's coming faster than we thought, right? So they identified this as a clear and present danger in our orgs. And the point that they were making is that we're getting complacent. We think we're growing at a steady pace and that we'll be able to handle the data growth. Now, they were talking generically, not in Salesforce, but you'll see in a moment that applies directly to our Salesforce orgs as well. But in fact, that there is a clear and present danger to our IT departments if we don't address this problem right now. So here's the analogy that they made, right? Is that when we run queries as IT folks, we're looking for a needle in a haystack. Well, what's happening, our marketing departments are coming to us and saying, well, we need bigger haystacks. We need to know more things about more transactions, about more customer touch points. So the haystack that they want us to amass information on is getting bigger, and the needles are getting smaller. And this, when you put those two together, you kind of begin to understand what they're talking about, what the caliber of the pain is that we're going to feel in the next couple of years. So this is not just hypothetical, it's not just me hand-waving. This is an actual database that my team and I worked on this year. And you see that in January we started slightly short of 30 million records. We came in right around April when they began to feel the pain. And while we were working on the problem, you see what's happened. When I built the presentation, we were at 70 million records, and I kept thinking, okay, well, that's what we're going to be talking about. That's what we built the slides on. Last night, I had to go redo the slide deck because they're now at 84 million records. So 100 million, I think, is before the end of the year. The more frightening thing is this asymptotic curve, even if you put it on a logarithmic scale, right? Normally, if you put data like this on a logarithmic scale, you should get a straight line. When you put this on a logarithmic scale, you're actually seeing it's still got a curve upwards. So it's accelerating at an accelerating pace. This is a real live case. I think the client might be in the room. I don't see them. Darn that Michelle Obama. But they're in town. They've seen this as well. And what we're going to talk about is, can Salesforce take us there? You know, many of us who've worked with SQL, we know that SQL can take us there, but can Salesforce take us there? So I don't want to belabor the point, but here's what this looks like, right? And I'll do it very quickly. The escalator is 30 meters down the line here. If we take 30 steps of 1 meter each, we'll be 30 meters from here. We'll be there, right? No big deal. Those are standard steps. On the other hand, Ray Kurzweil, right, in his book, The Singularity is Near, he talks about the idea that what frightens him is that this is comforting, we think we know it, but if we took those same 30 steps, but we doubled the size of each step, right? So we take the first step as 1 meter, and then the second step is 2 meters, and the third step is 4 meters, and you keep doing that. By the end of your 30 steps, you'll be further away than the escalator, and that seems to make sense. The question is, how much further are we going to be away from the escalator? How much further down the road are we going to be, right? Anybody have a guess? Right, the next block, LA. How about 26 times around the Earth? Right? This is happening to our data. If you go back and analyze the data in your company's database, if you're doing what we're doing at this client that we've got, you're doubling in size every 10 months, maybe even faster than that. And this is the problem you're faced with. Now, Salesforce is leading the way, right? They're not sitting idly by. They've scaled their own processing capability. Some of you may know that the Salesforce platform sits on top of an Oracle engine. And so part of the optimization that we're going to talk about is what can we do to optimize our queries. We can't really optimize it at the underlying Oracle SQL database level. But they are doing a number of things, they meaning Salesforce. And you see here that now they too are dealing with clients that quite easily have more than 10 million records. Steve Bobrowski runs the customer-centric engineering group. He's a good guy. If you get a chance to follow him, he's thinking about this idea constantly, and a lot of the ideas that you will see today are driven from some of the research that he and his team are doing. So today I'd like to cover the 6 steps that I think are necessary. And by all means, this is not an exhaustive list. It's what I think we can fit into 30 minutes or 40 minutes, I think, that they've given us. If you are like me, you come from .NET or Java, the old world SQL database design, and you're lulled into a sense of complacency because you think you understand all the Salesforce concepts, right? We look at our schema diagrammer, and we think we understand how the data is built underneath. And in fact, that's not 100% true. So one of the things I want to do is I want to talk a little bit about understand what you have at your disposal to control your data. Understand how your data is conceptualized. This is something that, as I work with large companies, I find that their processes are UML processes. And the data actualization in UML processes removes the relationship between objects. And I'll tell you what I mean by that in a minute. And soon you begin to lose track of how your data is actually structured inside your database. And so that's something that I want to talk about. This is a mindset change that if you can implement at your company, I think will do you a great deal of good. Understand and leverage indices. I think we know what those are. Ask for skinny tables. Does everybody know what a skinny table is? Let me see a show of hands of folks who've worked with skinny tables. Okay, you're in for a treat. Skinny tables are a Salesforce thing, and you can ask for them, and we'll talk about what you can do with Salesforce in order to implement skinny tables in your org. Develop metadata tables where possible. I debated whether to put this idea in here because it's not a hardcore technique, but it's one that we used very effectively in order to make queries performant. We abstracted data away from the large table, and I'll talk a little bit about that. And then when you have the option, you should leverage the new Lightning architecture and allow your data to be pushed to the client side and do some JavaScripting on your client side. And that's, we use that with this large client as well in order to give them performance, and we'll talk about that as well. Okay, so let's talk about what you can control and really what you can't. When you write a query or when you ask for a list view in Salesforce or you run a report, you're lulled into this sense of, well, I know how to write an optimized query because I come from the SQL world, and as long as I do my where clauses correctly and set up my indices correctly, I'll generally be okay. So you're thinking about the Salesforce relational database as you do your SQL relational database. And for the most part, that's correct, that if you have an idea of optimizing your database that you've carried over from your SQL on-site, on-prem system, that those methods will generally work in Salesforce. And I say generally because I will talk about the idea that you're actually not controlling the query that Salesforce executes. You're writing a metadata, if you will, which is then interpreted by the Salesforce engine. They go through a process of optimizing your query and then running it on their on the underlying database, and that middle process could eat your lunch, right? So we'll talk about what are the tools that they've given us to actually understand which queries are performant and which queries are not performant. So you think you're writing a SQL style query. Does it get executed as that? Maybe, likely not. Okay. Now there's another thing that I want you to understand, and that is how data is stored in the underlying database. When we run a query, let's say on the account object, and we combine the results of the query combine standard fields and custom fields, right? We expect that that's all somehow stored in the same place. It gets queried and off we go. In fact, that's not really true. Salesforce, in their underlying tables, they split up the data into many different tables. Objects tables, right? I used to use those words interchangeably, and I used to tell people, well, Salesforce calls it an object, it's really just a table. I'm beginning to understand that that's not true. The object is a virtualization of the underlying tables. So you run a query on the account table object, and in fact, the query runs across a number of different tables. So on standard objects, let me see whether it's on this slide or the next slide. I think it's on this slide. So there's one table that stores all of your standard fields for your standard object. It's one table, right? Multi-tenant, everybody uses one table, and it's got standard fields on a standard table. Does it change? Do those fields, does the size of those fields change? No, they don't. They're the standard fields that we know about. They exist on one table. So the next step is, well, where do they store my custom fields? Same table, account table. Where do they store my custom fields? Well, they store that in a completely separate table. Okay, so now your query that said select name, comma, daughter's birthday from account, right? Where one of the fields you want back is a standard field, and another field that you want back is a custom field. You're running it on a table that you think is the account table. Actually, what happens next is that the query goes down the Salesforce stack. It hits their database. Two separate queries are run. They're aggregated back together and returned to you as one query. So a lot happened in the process. You can't necessarily optimize that. If you've got custom fields, you've got custom fields. Nothing you can do about it, right? But understanding that this is happening will help you in the next stage in determining how to optimize the query itself. Custom objects are yet completely different. They store everything in a table, but it's yet another table away from the standard object and the custom fields object. Okay. Relationships, indices, all of those are stored in separate tables, and so there's a lot happening behind the scenes. In your SQL tables, your query is so much simpler. You run a query, there's an index table, there's the table that you're querying, put the two together, boom, you've got your result. Salesforce is way, way different underneath the covers, okay? So, earlier I talked about how you talk about your data inside your companies, right? Most of the large clients that I've got use UML diagrams for everything that they do. They use it for their processes, they use it to describe their tables. It's all done in the standard UML methodology. And by and large, I really like talking about our processes in UML. But the one place where I think that it does us a great disservice is this one place, right? When you're looking at your database on a piece of paper, a UML diagram completely obfuscates the relationships between those tables. You lose the crow's feet, right, on your tables. And I think that does you a disservice. It does everybody who's looking at your data a disservice. You've got marketing looking at this thing, and they don't understand why you can't extract this piece of data that they want. They're looking at the UML diagrams. They say, well, you know, this table is connected to this table. Why can't you get me the data I want, the results that I want? Well, of course, it has to do with the direction of the relationship and the information that's resident in how you talk about your data. Resist the urge, first of all, to look at your data in UML. If you have the option of doing this in your company, and Salesforce gives you a great tool, look at it in the schema diagrammer. There's a couple of third-party tools that let you diagram your data, including the relationships, the one-to-many relationships and those types of things. That is superior internally when you talk about your data to this. This will obfuscate and run you into trouble with other departments because there's just no relationship available in your data. This is actually the talking about your database. This is not the doing, it's the talking. So we talked about this, understand how your data is conceptualized. Okay, the next thing I want to talk about is indices. Indices in Salesforce are a little bit different than what you might have worked with in SQL. There are certain fields that are automatically automatically indexed and indexed without you doing anything straight out of the box, right? And on most objects, you see the list here on the left-hand side. These things on every object is indexed without you doing anything, all right? Then when you set up certain types of fields, those two are automatically indexed, and I think I've got it on here. Okay, so if you set up a field, you can, as long as you keep away from some of these types of fields, those two can be indexed, right? Automatically, if you declare an external ID, that causes it to be indexed, and of course you can do that on emails and on numbers and on text, right? This builds an index for you automatically if you do this, okay? Now, above and beyond that, and you should do this, right, is if you build a field that doesn't fall into the third category, you will want to request an index on a field that you've created, okay? And that's this second column that I've got here. You can open a case, give them the org ID, give Salesforce the org ID and the API name of the field that you want indexed. You open the case as long as it falls into this category. It's not a multi-select pick list. It's not a long text area, rich text area. And I want to talk about formula fields a little bit more, or of course an encrypted field. They can't help you there. Those fields are not indexable. But if it's not one of those fields, open a case, they'll index it for you. Why index your data? I'm hoping that's the next slide. Okay, yeah, why do you want to index your data? So there is this concept in database design, and it's not just a Salesforce concept, but there's this concept in database design that allows you that allows the underlying data engine not to have to scan the table every time you ask for data. It's two big buckets that your queries fall into. One is a full table scan. You did a select select name from database, didn't put in a where clause, that scans the whole table looking for the result, right? In addition, there are some, even if you put a where clause, if that field is not indexed, then it goes through the whole table. This is not a problem if your database is small. If the table size itself is reasonably small, under 500,000 records, it makes no difference. Your query comes back relatively fast. The other category is an indexed field. If you do a query on a table, on an object, and you give it a field in your where clause that is indexed, then Salesforce does not have to go through the entire table looking for your data. It hits the index table. From there, it vectors to the fields to the records that it knows are relevant, and it pulls them back. And I think I've got a couple of slides that shows you the difference in performance. Now, the difference in performance is, again, I want to emphasize that if it's a 10 millisecond query as opposed to a 1 second query, you don't care. You didn't even consider that. You went on with your business. But as the table grows, as your data increases, then that tenfold, 100-fold difference becomes very, very important. You know, a query of 2 seconds as opposed to 200 seconds. Now this becomes important. So those are the two buckets that I want to talk about. So there is one tool, and we could do an entire session on the query plan tool, but I, at the very least, want to introduce this tool to you. It's the Salesforce query plan tool, and it's available to you just by basically turning it on. It's not there on your standard screen. I'll show you in a moment how to turn it on. What the query plan tool does is when you present your query to the query plan tool, it gives you the different options that Salesforce itself is considering on the query that you want to run. And it'll give you 1, 2, sometimes 3 different paths that it's going to possibly consider. Now, underneath the covers, when you run a query, Salesforce runs the same query tool. It determines the most performant way of querying your database based upon this tool that I'm going to show you. And then it uses that path. Where you can influence your performance is by looking at your queries against that query plan tool and determining whether you have the option of optimizing one of your queries. And let's go there, I think, next. Table scan is just a full scan of the table. You want to avoid a table scan at all costs, right? You want to do indexing. Sometimes your query times out. Usually that's because it's trying to do a table scan. And let me see if I can get us to the query plan tool. So in your developer console, you can turn the query plan tool on by going to Help, Preferences, and one of your selections here is Enable Query Plan Tool. It's generally not enabled out of the box, but if you enable it, then what happens is in your query, down here, you see the execute, can you see the execute down there? Next to the execute, you now have another option called query plan, right? So So if you put in your select statement, just like you normally would, right? In this case, I said select ID and name from account where name equals gene point. And you know, when you run the query, it of course runs the query for you and it gives you your result here. But the more interesting thing is if you run a query plan against that, it gives you the different methods that Salesforce is considering running that underneath the covers. And you see that it's got a couple of things. Now, I will make some comments about this, and that is this. In the notes section, the notes section is new, and it's not always, it doesn't always tell you what you think it tells you. I think it's an important addition, but you see, we haven't queried is deleted, and yet every time they generate this, they'll give you a note on is deleted. Ignore that, right? But the additional notes at times become important. It tells you what's going wrong with your query. On this one, the table scan is costing us 0.6033 aggregate points, right? And the importance here is just as compared to the other option that we've got here, which is a 0.5. And so this is a simple case. This would run it not as a table scan. You want to avoid table scan, so that's fine. Let's run a couple of additional queries that are a little more fun. Correctly. Okay, so this is slightly different. This query is asking for the ID and name where part of it is a not something. Okay. Follow this with me. When I query a table and I say where name equals this, it's looking for a very specific thing in the database. When I say is not this thing, in this case is not gene point, now it has to go through a lot of additional analysis. It looks at every table, even though it might be indexed, and it says, is this not equal to that? If yes, then put it in this bucket of results. Not equal to will eat your lunch every day. Okay? Avoid those like the plague. If you can build another field that somehow negates that for you and query that field instead, you're better off doing that. Running a query like this, not equal to something, it'll run. There's nothing illegal about that, but it slows you down like crazy. Did I run that yet? Let's run that. Look what happened. Remember, our numbers were in the 0.5 and 0.6. Okay? This relative cost is above 1. Above 1 queries are bad. You want to avoid them at all cost. Your query plans need to be under 1.0. Okay? So this is telling you right away that it's time to do something about this type of query. This is the wrong query to run against your database. Let's run another one and then move on, because we are running a little bit short of time. Actually, let me do this. I want to show you just where ID Here's a really performant query, right? I'm going to take the ID, which I know is indexed, and I want to bring it down where is it the correct place, where ID equals Control V, and let's run a query on that. And you'll see we're now into the 0.1 category on cost, okay? Indexing is your friend, right? If it's not naturally indexed, then by all means request that Salesforce index it for you. And with that, let me talk about a couple of items. Now, I'm going to put this slide on the screen, and I want you to take a photograph of it. I'm not going to talk through it because there's a lot of data there. There is a document that talks about what all these different columns mean. If you Google Salesforce query plan tool, it'll basically give you an explanation of each of the fields on the query plan. This is the best friend you've got as your database starts to grow. If you run your queries against this, it'll tell you if your database is indexed correctly, whether you're going to time out on a query or not. This is your best friend. And finally, let me okay, the last thing I want to talk to you about is metadata tables where possible. Whenever you can abstract your large database table into a group of records that can be abstracted onto another table, do that. Let me tell you what I mean. In this client's case, they had 84 million leads. Well, the leads fell into neighborhoods, and we were able to extract the psychographics of that neighborhood, income levels and what kind of car they drove, and that sort of thing could be abstracted away from the 84 million records. And we stored that information in a metadata table, which was then the root of our query, right? So instead of running, and I think we went down from 84 million in the child table to 400,000 records in the metadata table. So now all the queries, if I needed all neighborhoods or all houses that had an income level of $500,000 or more, I could run that query against the metadata table, right? Against 400,000 records as opposed to 84 million. Do this, think about this. This is actually a design phase item that you should be thinking about, is how do I abstract information away into a metadata table? Perfectly okay to have a lookup relationship, right? Because each of those houses then belong to a neighborhood. Lookup relationships, those lookups can be built and maintained in batch mode after the fact. This is item number 6 on my list. I think you should be doing this sort of thing. Guys, my buzzer is blinking at 0 on me right now. I'll take a couple of quick questions. Christy, do I have time for a couple of quick questions? No? Okay. I'll be up here, guys. I appreciate you coming. If you have questions, specific questions, by all means, come up front. I'd love to talk to you about your specific problem. Otherwise, have a great Dreamforce, guys. Thanks for coming.